Hey guys, in this video we're going to be learning about projection and also unit vectors. So looking at the diagram on our left over here, we see that we have two forces, F1 with a magnitude of F1 equals 50 newtons, and we can see that it's going from point A to point B. And then we have our second force, which is over here. It has a magnitude of 30 newtons, and it goes from point A to point C. Okay, so to get our magnitude of the force F1 projected on AC, this is the formula we're going to need. So the force vector F1 with the dot product of the unit vector of AC. Okay, so looking at what we're given the magnitude of F1, but we're not given the vector of the force. So to get the vector of the force, to get F1, the vector, we're going to have to multiply the magnitude times the unit vector. So I'm going to put this in parentheses, times the unit vector from A, B. Because we're choosing A, B because F1 starts at A and ends at B, this point right here. So let's go ahead and get started. We know F1 is 15 newtons, and that's given to us in the problem. To get the unit vector of AB, what we're going to have to do is find AB first. So AB really equals B minus A. And what I mean by that is we're going to take each component and subtract from the other. So it's going to be BX minus AX, comma BY minus AY, comma BZ minus AZ. Okay, so let's go ahead and solve this. So the vector AB equals, so we have bx, which is 0. So this is our x, y, z. And for a, we have x, y, z. So we have 0 from over here. And then for ax, we have 2. So minus 2. For by, we have 3. For az, or ay, sorry, we have negative 3. So it's going to be minus negative 3. Comma, for bz, we have 0 minus az, which is 3. So when I add or subtract everything, I'm going to get AB equals negative 2, comma 6, comma negative 3. Now we have to understand the unit vector is unitless, and it's just a direction. What we have here is a vector, and to get its direction, what we're going to do is take the magnitude and divide by this. We have this direction and magnitude over here in this vector. So we have both. I'm going to write that down. So both direction and magnitude. But we only want the direction because the problem is giving us the magnitude of F1. We just need to know the direction to get this vector force 1. So what we're going to do is find the magnitude of AB and then divide it from this vector over here to get direction that is unitless. So AB's magnitude, which again we represent with these absolute value signs, is going to be negative 2 squared plus 6 squared plus negative 3 squared, and then we're going to take the square root of that. So if I plug this in, I'm going to get 6 plus 9, I'm going to get 7 for my magnitude. Now to get the unit vector, so UAB, it's going to be negative 2, comma 6, comma negative 3. I'm going to take the vector and divide it by the magnitude. So so what I'm doing is direction, magnitude. This is what the vector has. I'm dividing it by the magnitude. So essentially, I want to be left with just the direction. Okay, so this would result in -2/7, 6/7, and -3/7. Now that I have my unit vector for my force F1, what I can do is plug it into this formula. So I'm going to write this over here. So I'm going to have F1, the vector, equals F1, the magnitude, which is 50 newtons, times this direction. So that's -2/7, 6/7, -3/7. So when I solve for this, I'm going to get that this equals 100/7, or -100/7, F1 vector, comma, so 50 times 6 divided by 7, that's going to give me 300/7, and then 500 times 3, -3 divided by 7 is going to give me -1,500/7. Or, no, sorry, 150. That's too much. I had an extra 0. Okay, now that we have our F1, all we need to do now is find our unit vector AC, because that's where it's going to be projected. The force is going to be projected on. So we're going to do the similar steps on how we got the unit vector for AB. So for the unit vector AC, so UAC, what we're going to do is, I'm going to use a different color actually. UAC, what we're going to do is first find AC. So AC is again really C minus A. So we're just flipping them around. And we're going to take each component and subtract. So for C minus A, it's going to be the C component, so CX minus AX, comma, CY minus AY, comma, CZ minus AZ. Okay, and then going to our diagram to look at what each of these values are, CX is, so XYZ, so CX is -2. -2 minus my AX, which is 2. CY is 3. So 3 minus my AY value is -3. So minus -3, comma, CZ is 4. So 4 minus AZ, which is 3. So I'm going to get -3 here. I calculate this, I get AC equals -4, comma, 6, comma, 1. Okay, so now we have AC. Now we have something that has both magnitude and direction. Magnitude and direction. But we only want direction because we want the unit vector. And that's something that's unitless. So what we're going to do is find the magnitude and divide from this vector. So the magnitude of AC is going to be -4 squared plus 6 squared plus 1 squared, all square rooted. So if I calculate this, I'm going to get that the magnitude of AC is going to be root 53. So root 53. So if I take my vector, which is over here, and divide it by root 53, I'm going to get UAC equals -4, comma, 6, comma, 1 over root 53. And I can write this as the vector of -4 over root 53, comma 6 over root 53, and then 1 over root 53. Okay, now that I have the unit vector AC over here, I can now do the dot product of F1, the vector, dotted with the unit vector AC. So we want the dot product. So to do that, I'm going to first copy down my F1 vector, which is over here. So that is going to be F1 equals negative 100 over 7, comma 300 over 7, comma negative 150 over 7. And then I'm going to write down my unit vector AC over here. So UAC equals negative 4 over root 53, comma 6 over root 53, comma 1 over root 53. Okay, to do the dot product, all you're doing is multiplying each component together. So the x's are going to be multiplied together, the y's are going to be multiplied together, and the z's are going to be multiplied together. And then we're going to add each of them up. So negative 100 times negative 4 over root 53. So negative 100. So if I do negative 100 over 7 times 4 over root 53, I'm going to get an answer which is approximately, so that's going to be negative 7.85 plus, I'm going to do the blues, so I'm going to multiply the blues together, the y components, so 300 over 7 times 6 over root 53, that's going to give me 35.32. And then if I do the z's together, so z's, I'm going to do negative 150 over 7 times 1 over root 53. I'm going to get minus 2.94. So let me color code these real quick. So I'm going to make this pink or red, and then this is going to be blue, and this is going to be green. Okay, so adding or subtracting all of these would be negative 7.85 plus 35.32 minus 2.94 is going to give me the magnitude, which is 24.56. And that is my answer. And I can use my newtons. So I'm going to write newtons, and that's officially my answer. Thanks for watching.